Hello, 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 and welcome back to Shiksha Costa. Today we're going to look at the something called the future value of an annuity. And this is part of solving financial problems that involve exponential functions. So today we're going to learn what an annuity actually is. And basically, we're going to figure out how to calculate the total future value of many, many, many investments, not just a single one, multiple investments, as long as they're made at regular intervals. So by the end of this, you are successful or you will be successful if you can explain the meaning of the term annuity by doing an investigation through using numbers and using graphical representations that use technology. To start off, let's think about this question. I've used this in an example before, but basically to save up for their first year of college, which they know will cost $2,686, Levin wants to invest some money in grade 9. And this is 4 years before they will actually go to college. They managed to find an investment product that guarantees them a return of 2.7% per annum, which means per year, and it compounds every week. So how much should they invest today? No, keep in mind that they've got 4 years for their money to grow until it reaches this amount. This is the amount of an investment. It is growing with compound interest. So we have to use the compound interest formula. And we know the future value, the amount in the future is $2,686. We know that the interest rate for one period is, well, it's not 2.7% because this compounds every week. So basically, that compounds 52 times a year. So in that one period, we don't get the full 2.7% because this is per year. We did not wait a full year yet. So we have to take that and divide it by the frequency. So 0.027, which is 2.7% as a decimal, divided by 52 weeks in a year. And that's going to give me a really ugly decimal. So I'm just going to leave it the way it is as a fraction. That's the interest rate per period. The number of periods in 4 years, if it compounds every week, well, that means we have to take the 4 years and multiply it by 52 weeks to get a total of 208 weeks. And now let's plug in the variables that we know. That's the future amount, that's the interest rate per period, and that is the number of periods. And if we were to just divide both sides by this number right here. You can try putting it into your calculator if you'd like. You could do 0.027 divided by 52 plus 1 and then to the power of 208. And just recognize that whatever that number is, we'd have to divide it, divide the right side by that, and then divide the other side by it as well to isolate p. And when we do that, something like this should happen. You'd divide both sides by that amount. And notice what I did. I just wrote the entire expression the way you see it here. And that got me $2,411 and about 10 cents once I did the same thing to the left side. And that's the amount she would have to invest today if she wanted it to grow to $2,686 in 4 years. Now, is it actually likely that a grade 9 student has access to $2,500 basically? That's a pretty high number. And most students start working in grade 9. So it's very unlikely, in my opinion, that somebody would be able to have access to that. And in fact, most savings plans sort of would be really faulty if they assume that you start off by already having a bunch of money. Most savings plans, instead of involving making one giant contribution and letting that grow over time, people generally just take a little bit of their paycheck, so a little bit or a smaller amount at regular intervals over time. Either way, whether you make one big deposit at the start or many small deposits over time, you could still end up getting the same future value. And the way to think about a math situation like this is that each of these is a separate investment. They all have the same present value because you're saving the same amount. They all are also growing at the same rate, so the interest will be the same. But because this one has all this time to grow, this one has less time to grow, and this one has less time. Because all of that is true, each of these is growing for a different length of time, so they all have different terms. And let's see an illustration of what this might look like, and I'll give you a chance to work on this yourself. Suppose you had $100, and you were saving $100 every single month. how much would you end up with at the end of 1 year if your investment appreciates by 7% per year and it compounds monthly? And to solve this, I'm going to ask you to pause the video in a second, and I want you to fill out this table here. So, for example, this one would be the first investment. You're doing it at the beginning of the year, so in January, and it's if you're going to wait until the end of the year, it's going to have 12 periods, 12 months to grow. So you can use the formula for compound interest to find out what is the future value of this first investment. And I'm going to do that first one for you, and then you can pause the video and do the rest. So this first one would be the present value of $100. That's how much we're saving, times 1 plus I. So this is the interest rate per period, 7% divided by 12 periods. 7% per year divided by 12 months in a year. And all of that to the power of 12, because this investment, the first one, has 12 periods, 12 months to grow before the end of the year. So its future value will be about $107.23. Whereas if we looked at February, it has some very similar characteristics. It's got the same present value, it's got the same interest rate, but its term, when you invest money in February and you're going to withdraw it at the end of the year, well, you only have 11 months to grow. And so by the end of that, you would only get $106.61 out of the second investment. So pause the video here, copy down this table, and go all the way to 12 investments and see if you can calculate what the future value is of each investment, and we'll break it down in a second. Okay, so let's take a look at that table. It should look something like this. You should have been able to calculate the future value for each of these separate investments. So in March, that was the third investment. It only had 10 months to grow, so the exponent was 10. April only had 9 months. May only had 8, and so on and so forth. You can see that because they have less time to grow, the future value of them seems to be growing less as well. The last investment that we made, the one in December, only had 1 month to grow. So we only got 58 cents in interest. And this is a neat little chart that shows the value of each of these investments. January, which we invested over here, this is the time or the number of months since the start of the year, and this is the value of every investment. If this is January's, that's our first investment, that grew over time until it reached 107.23. $107.23. But notice the next investments, they don't have enough time to grow, because over here is when we are withdrawing all of them. We only have 1 year to save. So how much money do we have overall in this year? Pause the video and see if you can figure out how much money you have in your account by the end of the year. Hopefully you recognize that, well, if this is the value of the first investment and this is the second, if I want to find out how much money I have to add up all of my investments, and the total ends up being $1,246.48. Now, there is a way to come to this number without doing all of this work, especially if you're talking about making monthly contributions or weekly contributions. Are you going to do that 52 times? What if you were talking about 30 years? Are you going to do that, hundreds and hundreds of times to find all of this and then add them all up? Well, if you say to yourself that's too much work, you're thinking like a really good mathematician. In fact, we're going to use a TVM calculator. A TVM calculator can be used to find the future value of this situation. This is called an annuity. When you make multiple investments at regular intervals and you are trying to find the total value of all of those investments, and they all have the same interest rate, well, that is exactly the situation that people call an annuity. And using a TVM calculator, you can put in 0 for present value, because you're at the very start of the period, at the start of the term, you had no money in your account. But every payment that you made, the size of every regular payment was, let's say in this case, $100. The annual interest rate you got was 7%, but there were 12 periods because it compounds every month. Well, if you fill all of that into a TVM solver and you click on that button that says FV or future value, it will automatically calculate that your future value is exactly what we got over here. Okay, $1,246.49. Well, it's very close at least. I think maybe if I had switched it to end, it might give me the number that we got here. Also, notice that it gave me a negative number. For some reason, you may have to enter the payments as a negative number, or the future value will be negative, but the amounts will the absolute value will be exactly what we were looking for. So we started out with nothing. We made deposits of $100. We did that at the beginning of each period. We got 7% per year as our return rate. And we did that 12 times because each period was exactly 1 month. And that gave us our future value. So, an annuity is a financial product. It involves multiple regular payments. And what does it mean to find the future value of an annuity? It's the total future value of all of these regular investments. And you can use a TVM solver to find out the total future value, or there's actually a formula you can use instead. So the formula is over here. Notice how quite big it is. There are a few variables that you already know, like I is the interest rate per period, and n is the number of periods, but notice I actually appears twice. It's the same value in both instances. Notice there are a few new variables involved. A capital R. Capital R means that is the amount of each regular payment, and FV is the future value. Now, there's another formula. Well, it's the same formula, but it just, if you, instead of calculating the future value, if instead you want to calculate the size of the payment that you need to make in order to reach that value, well, you just have to isolate R. But all of this entire expression will remain the same value. So that's going to be just some number. And if we can divide by that number, then that would cancel it out here. And then if we divided the other side, we'd get FV divided by that expression. That gives you the size of the regular payment that you need to make in order to reach that future value. This is the most common and powerful way of saving for your retirement. And the most powerful use of this, therefore, is to calculate your retirement savings. For example, in this situation, Yendrix is following something called the 50-30-20 rule. That tells you to spend 50% of your paycheck on the things that you need, 30% on the things that you want, and 20% just save it for the future. So that's what Yendrix does. Her paycheck, which is biweekly, is $2,500, and she spends 50% of that on her needs. She spends 30% on the things that she wants, and she saves 20% for the future. And she does that by investing in it, investing that money, that 20%, in a stock that will return about 14.12% per year, which is really, really good. And it will do that on average, and it compounds at the same frequency as her deposits, which is bi-weekly. Bi means two, which means this is every 2 weeks. The question is, if she does this every 2 weeks, she gets $2,500, she saves 20% of it, how much will she have by the end of her career if her career ends up being 30 years long? This is a great sort of problem that everybody should do, at least once every year or so, just to get a handle on what their financial future looks like. In this case, Yendrix is doing it at the very beginning of her career, which is excellent on her part. In this situation, she is making regular deposits. So every 2 weeks, she's making a new investment. And that investment product is called an annuity. And we know the formula for an annuity is given right here. Let's find the variables that we know and find the value of the future, or the value of this annuity in the future, by calculating all of these. So let's see, we need R. R stands for the amount of each regular deposit. And we know that every 2 weeks, she saves 20% of her paycheck. So what is 20% of $2,500? 0.20 times 2,500 is $500. She saves $500 every 2 weeks. That's the frequency. It's bi-weekly and it compounds. So the compounding periods are also the same frequency as her deposits, which are bi-weekly. So that's 26 times in a year. There are 52 weeks in a year, but if you are only compounding it every 2 weeks, then we can divide that by 2 to get 26. So there'll be 26 periods of 2 weeks in 1 year. That's the frequency. And the interest rate for one period then can be calculated using this. It's not 14.12% because, it compounds every 2 weeks. We have to take this rate and divide it by the actual frequency. So we take the annual rate divided by the frequency. That gives us 0.1412, it's 14.12% as a decimal, divided by the frequency, which is 26. And that actually doesn't give us a nice decimal number. So I'm just going to leave it as a fraction. The number of periods, well, she's doing this for 30 years, right? To calculate the number of periods, we take T times F, which T is the term in years, and F is the frequency. So in this case, there's 30 years times 26 periods in 1 year would give us 780 times. So for 780 times in her life, Yendrix is planning on saving $500. That's every 2 weeks for 30 years. And if we do all that, we can find the future value. So let's plug in all of the values that we know, 500, 0.1412 over 26, that's I, and N is 780. Just these three variables will go in here, here, and here. And when we evaluate this using your calculator, you'll get a number like, whoa, $6.2 million. That's quite a lot, right? This is a very reasonable paycheck for Yendrix to be earning. And for her to save 20%, if she invests it with a really good interest rate, she can end up retiring with, $6 million in the bank. That's a ton of money. Unfortunately, that's not enough for Yendrix. Yendrix wants to retire with $10 million instead. She wants to live that bougie life. So how much should she save every single paycheck if that's the case? $500 is not going to be enough. Well, we have our same variables from the last situation. The interest rate has not changed. The length of time that she's going to save, the number of periods, that hasn't changed either. And neither has the frequency. So she just actually needs to save more. The amount of each regular deposit is what she doesn't know. It's got to be higher than 500. But she does know the future value needs to be 10 million. So we can actually use that version of the formula that has R isolated. We can plug in our values. 10 million is the future value divided by all of this. And we know that I is 0.1412 over 26. And N, the number of periods, is 780. And this is pretty tricky to put into your calculator. So please try to do your best to do that one step at a time. In fact, pause the video here and see if you can do that. Well, hopefully you found that the answer was the same as mine, $806.43. That's how much she would need to save bi-weekly instead of 500, which is quite a bit more. But if she does that and she gets this interest rate, she should end up with $10 million at the end of 30 years. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.